Welcome to Finding Zeros of Polynomials. Today we are going to find the zeros in factored form. So that means we actually have to put it into factored form. So our goal when we want to find the zeros is to put it in factored form and then set all the factors equal to 0 and find the roots, just like we did with quadratics. So the first one, luckily for you, is already in factored form. So really, when we're trying to find the zeros, we're really setting that function equal to 0. So I'm just going to rewrite this here. Because we're trying to figure out, well, what x values are going to make the whole thing 0, or the y value 0. So since it's factored, I have multiplication between all of my three factors. So I'm going to see, well, the whole thing would be 0 if this one was 0, so x equals 0. So if x was 0, it'd be 0 times these numbers, which wouldn't matter because it's 0 times and it's true. So there's one root. Now I can look at my next factor. I've got x minus 4. So if that was equal to 0, then it would be 0 times all of this, which would just be 0 again. So that one would be x equals 4. Right? 4 minus 4 is 0. And then my third one, right over here, that'd be x plus 3 equals 0. So I know it would be x equals negative 3. So I've got 3 roots, which means that that graph should cross that x-axis 3 times. So let's check. I've actually graphed it on the graphing calculator. And if you look, it crosses here at negative 3, 0, and 4. Which matches up with what we got. So that is how we find those zeros when it's in factored form. So the question is, well, what if it's not in factored form? So to get it there, we can use division and factoring. So if we know one of the factors, we can divide the polynomial by it to break it down, which we've done with long division and synthetic division. And then whatever we have left, we see if we can also factor that. So let's try the first one. So we have x plus 3 is a factor of the polynomial x cubed minus 19x minus 30. So find the other two factors and then the zeros. Once we have the factors, then we know the zeros. So let's see. We know that x plus 3 is a factor. That seems important. I'm going to underline it. And here's our polynomial. So I know that this is a factor. So that means when I divide it, I should have a remainder of 0. So that way I will now divide to see what would be left after I divide by that factor. So I'm going to use synthetic division here. So I've got my little box, and in this box is going to be my root, which here would be negative 3, right, the opposite of this. And then I need my coefficients. So the first one is a 1. And then I notice, oh, we skipped the x squared term. So we need a placeholder there. So that'd be like 0x squared. So I've got 1, 0, negative 19. And then my last one would be negative 30. So let's go ahead and do that. So we bring down the 1. Right. Then 1 times negative 3 makes negative 3. Add those down. That's negative 3. Go back. Negative 3 times negative 3 makes positive 9. Negative 19 plus 9 makes negative 10. Negative 10 times negative 3 makes positive 30. And when I add these two together, I have a remainder of 0. Which is good because I knew it was a factor, so that meant my remainder had to be 0. Now I'm going to write down what I have left. So this is my number, my x term, and then my x squared. Oops. So let's see, that should be x squared minus 3x minus 10. So once I have my polynomial, I'm now going to look for, can I factor this? So we did some factoring at the beginning of the year. We did like the little x method. where we put the C in the top, the B in the bottom, and then we figured out what two numbers here would multiply to be C and add to be B. So we've got negative 10. So it could be 1 and 10 or 2 and 5. It's negative, so one of them has to be negative. And I know they should add to be negative 3x, so probably the bigger one is going to be the negative. And 2 and negative 5 does add to be negative 3. So I know it's 2 and negative 5. So when I factor that now, I've got x plus 2 and x minus 5. Okay. So these two multiplied to be negative 10. Forgot to put that in there. And they added to be negative 3. All right. So now I have factored this, and I also originally knew that x plus 3 was a factor. So if I want to have the full factored form of my polynomial, I should put all of my factors. So that means x plus 3, x plus 2, and x minus 5. So all three of these were factors of our original polynomial. And so I found the other two factors, right? That was x plus 2 and x minus 5. So that's part A. And then now I need to find the zeros. So I'm going to set this equal to 0. And now it looks a lot like what we did up here. So each one can be set equal to 0. If you want to take a little shortcut and just kind of say, okay, this is going to be x plus 3 equals 0. So I know x is negative 3. And then here, x is negative 2. And then here, x would be 5. So that means when I graph that, it should cross the x-axis at those 3 points. So let's go ahead and actually graph that in there. Oops, this is a minus. So if I go to my graph, okay, so I went to a new document. I'm going to open my graphs. And now I'm just going to type in that equation because I want to actually confirm this. So I'm going to see, was my answer correct? And this might be a good way too to actually find out what these factors would be. So let's graph that. So I've got x, and then I'm going to use this little caret, they call it, the exponent of 3. And then I need to move over so that the rest of it does not go into the exponent. So it was x cubed minus 19 x minus 30. Enter. And now I can see that graph. So let's check, okay, how many times does p of x cross the x-axis? 1, 2, 3. What are the values of x where it crosses? Negative 2. Or sorry, negative 3, negative 2, and 5. Negative 3, negative 2, and 5. We got that from the graph, which actually matches up with what we had here. So there were 3 roots, and these are where it crossed the x-axis. So 3 x-intercepts.